deliver blood to the abdomen and lower extremities, so that everybody gets a little oxygen. That's the way we want it. Okay. Now, that's kind of an overview. That's kind of a little bit of an overview. Now, when I draw a picture of the heart, notice that the great vessels all come off at the very front. Okay? I'm going to draw my first drawing. It's going to be a frontal view, a frontal section, but kind of behind the great vessels. So in my initial image of the heart that I'm going to draw here, you're not going to see the great vessels. It's not that they aren't attached. It's that the plane of section, the plane in which I'm drawing the heart, is behind or posterior to those great vessels. That makes sense? Let's see if this one works. That's not dark enough. A little bit better. That's still not terribly dark, is it? Which one? You think this one's good? Yeah, that's pretty good. So, I've sectioned the heart in frontal plane, and in this particular plane we can see all four chambers. We said that the upper chambers are called atria. Now if I want to use the singular, it's atrium. I convert this um to an a if I'm using the plural, if I'm talking about both atria. So this would be an atrium. In fact, this would be the right atrium. And over here would be the left atrium. To refer to the lower chambers, we use the term ventricles. And so on the right side, of course, this would be the right ventricle. And this here would be the left ventricle. Now, we call these partitions that separate one side from the other. We would call this a septum. Okay? Because this separates the right ventricle from the left ventricle, we would call this septum an interventricular septum, or IVS. I'll spell it out. Interventricular. And a septum. Yeah. Okay? But above, the part that then separates the two atria, we wouldn't call that interventricular. What would we call that part?
Interatrial.
Say it.
Interatrial.
Interatrial septum. Yeah. This part up here would be IAS. when we looked at the heart, I said that there were valves that control flow from the upper chambers into the lower chambers. Okay? The type of valve, this isn't the name of the valve, but the type of valve that these two represent would be called atrioventricular valves, AV valves. That's not the name of these valves, it's the type, because they're situated between the atrium and the ventricle. So these would be called atrioventricular valves. And atrioventricular valves are different from the other two valves, one of which sits at the base of the pulmonary trunk, the other sits at the base of the aorta. Okay? The other two valves are called semilunar valves. But AV valves are different from semilunar valves. They're more complicated. Okay? So semilunar AV valves rather have three components. They have cusp, and the cusp is just a flap. Okay? The tricuspid valve, in fact, has three cusps, whereas the mitral valve on the other side only has two. So one of the components is the cusp. Okay. Now, extending inward like a little finger from the wall of the heart and from the septum, you have these little finger-like projections called papillary muscles. And these papillary muscles are part of the valve apparatus.
So are there many, or you just, like, are there only a few, like you drew?
Well, you'll see it's a variable number.
Okay.
It's not constant, okay, between one heart and another.
Okay.
But typically there are two or three. Sometimes there's four. Okay? And then these papillary muscles are attached to the valve cusp by string-like structures called chordae tendineae. And I'm going to draw these. Little parachute strings coming down and attaching to the papillary muscles. Okay. So that's the third component of the valve. These chordae So these three components, by the way, are only components of AV valves. When we later talk about semilunar valves don't have papillary muscles and they don't have chordae tendineae. These are features only of AV valves. Okay. Now, the AV valve on the right side, this one right here, it has a name. It's called the tricuspid valve. Whereas the AV valve on the left side is called the mitral valve. Let me help you remember this. You know how when we're all studying on our own and we have to kind of come up with a list or name some structures, we develop our own little personal mnemonics that may make sense to us. Okay? that help us remember these names? Well, I've come up with a nice mnemonic, I think, for the tricuspid and mitral valve. Okay? The tricuspid valve sits below the right atrium. So I think a mnemonic, RAT. Right atrium, right atrium. The mitral valve sits below the left atrium. So I think of the word LAM. Left atrium, mitral, put a B at the end. But the B is silent because we no longer use the term bicuspid. So we make this silent. Now along the back wall of the right atrium here. This is all right atrium. Inferior vena cava, superior vena cava. Along the back wall, we see here the coronary sinus draining into it. Okay. So let's put that in our drawing. Along here is going to be the opening from the coronary sinus. Now, there's another name. When a vessel opens into a chamber or into another vessel, that opening is called an ostium. So that would be the coronary sinus ostium. Okay, we're learning all kinds of new words. Okay. Okay. And what I want to teach today is that learning is fun. Can everybody repeat that? Learning is fun. Okay? A little bit more enthusiastically next time. All right. So we've kind of drawn the basic structure of the heart now. If I were to look at, by the way, the free wall, like here's the free wall of the left ventricle, I would discover that if I cut off, slice the part of this free wall, there would be 3 different layers. Okay. The innermost layer, okay, that in fact lines the free wall, and also lines the surface of the papillary muscles. It's also going to line the surface of the valves like this. Atrium. This inner lining is called the endocardium. It's not very thick. It consists basically of a simple squamous epithelium and some underlying connective tissue that supports it. Let's look at the outermost lining. I'll put this in orange. This outermost lining, what do you think we call this?
Pericardium.
It's got 2 names. We can either call it the epicardium or another word for epicardium, another term, is the visceral layer of the pericardium. So another term for the epicardium is the visceral layer of the pericardium. And this is a serous membrane. It lines a sac, the pericardial cavity, that's closed to the outside. Hence, it's one of those 3 major serous membranes: pericardium, pleura, peritoneum. By the way, when this visceral layer, remember visceral means organ, so the layer of the pericardium that lines the organ is the visceral layer. When it reaches the base of the heart, like these great vessels, it reflects back upon itself, like I'm showing here, and gives rise to the parietal layer. Yes. Okay, so the heart actually sits within a pericardial sac. The visceral layer can also be called the epicardium. This here would be the parietal layer. Okay. And these are both serous membranes. They both enclose a space, the pericardial cavity, that's closed to the outside. And again, its composition is the same, simple squamous epithelium with a little bit of connective tissue. Now, the middle layer that sits between the endocardium and the epicardium, and this is the thickest layer, is called the myocardium. And the myocardium is made up of cardiac muscle. The myocardium is sandwiched between, it's the thickest layer, the layer that contracts. So, here's the myocardium here. So just like the walls of the heart are made up mostly of myocardium, so too is true for the papillary muscles. When the walls of the heart contract, so do papillary muscles. When the papillary muscles contract, they put tension on those chordae tendineae. I think that I've told you the story about the gentleman who came in with a stab wound to the abdomen. I told you that story? Oh, I thought I did. Okay, I'll tell you a little story to look at that clinically.